So we've been using our integrals to find the area under a curve, but what happens if we have two curves? So what we're going to look at is finding the area between the two curves, and it's actually pretty straightforward. Since we know how to find the area under one curve, well, if we can find the area under both and find the difference. For example, in this picture here, so we have y equals x squared, which is this bottom curve, and y equals 2x, which is the upper curve. If I found the area below 2x, and then I subtract the area below x squared, well, it's going to leave me with the area between those two curves. I mean, it's as simple as that. So what we're going to do is we're just going to find the integral, and we're going to take the upper curve minus the lower curve. Okay, so finding the area under the upper curve, subtracting the area of the lower curve. In this case, we would need to know the bounds, so our a to b. One way that we can figure that out is setting our functions equal to each other. So x squared minus 2x, x squared equals 2x. Then since we have the x squared, we're going to subtract the 2x over, because that's how we solve our quadratic, setting it equal to 0. So I'm going to go ahead and factor out the x. So here, I see my bounds are going to be 0 and 2. So I can go from 0 to 2, upper curve, which is 2x, minus lower curve, which is x squared, dx. And that's going to find the area between these two curves. So I'm going to antiderive 2x, so I'm going to get x squared, antiderive x squared, which is x cubed over 3, and I'm going from 0 to 2. So I plug in 2, 4 minus 8/3, and when I plug in 0, we get 0, so that's nice. So that's going to be 12 minus 8. The area between our curves here is 4/3. Sorry, I'm at the bottom of the screen. 4/3 units squared, because we're talking about area. Plain and simple, okay? If we had to worry about being, instead of having like an upper curve and a lower curve, we have a right side curve and a left side curve. We're going to do the same thing, but we're going to do it in terms of y. And depending on how you look at it, you're just going to take your right side minus your left side. Okay? All right, so we've got one more example over here. We're going to find the area between sine and cosine. And I drew that a little wonky, but we get the gist. Our sine wouldn't look like that, actually. Sine would look more like this. So we've got more of a cool curve looking thing there. Okay, either way, we know that sine and cosine, they're going to be equal to each other at pi over 4. So I'm going to find the integral from 0 to pi over 4 because it said the y-axis, and that's how we got our shape. My upper curve, this is cosine, and our lower curve is sine. So this is going to be the cosine of x minus the sine of x. And once it's set up, I'm ready to just antiderive. So the antiderivative of cosine of x is sine of x. The antiderivative of negative sine of x is cosine x from 0 to pi over 4. So I plug in pi over 4. So the sine of pi over 4 is root 2 over 2. Cosine of pi over 4 is also root 2 over 2. Minus, if I plug in 0, sine of 0 is 0. Cosine of 0 is 1. So I am going to get 2 root 2 over 2, which is root 2, minus 1. So the area between our curves here is root 2 minus 1 units squared. Okay? If you got questions, let me know. Enjoy!